time you'd like. Pythagoras' father said, "Son, on second thought, maybe you should tell me about the distance to Crete." Pythagoras explained, "On our island, Samos, forms a right triangle with roads in Crete. If I call the sides of the triangle A, B, and C, I can use my right triangle pattern, a squared plus b squared equals c squared, to find out the distance from Crete." So he has their island, Samos roads, where his dad usually sails to, and they know that's 111 miles. Roads to Crete, they know is 148, but they're trying to find, of course, the hypotenuse. To find C, the distance between here and Crete, I had to find what number multiplied by itself equals 34,225. And he goes through the math, 148 squared, 200 squared, etc., and finds 34,225. The distance to Crete is 185 miles. Everyone was amazed. Pythagoras' father clapped him on the back. "Good thinking, son. You'll make a fine merchant someday." Pythagoras' mother said gently, "Or perhaps he can use his mind for other things." What did Pythagoras become?
A mathematician.
Philosopher, and a teacher. His father nodded. "Son, with your clear thinking, you become a general, a senator, a teacher, or anything you want. It's your choice." Pythagoras smiled and hoped to do some great things in the future. A few days later, Pythagoras saw his father's boat sailing into the harbor. His father ran to greet him. "Pythagoras, you were right. I made it to Crete in record time." Pythagoras looked up at his father and said, "You were right, too. I just had to look at things from the
right angle."
All right. So, Pythagorean theorem is only used for what kind of triangles? Right triangles. And the shortcut way, his pattern, as he described it, he called a squared plus b squared equals c squared. So, in a right triangle, we have three sides. What are these sides referred to as? We use A and B in the Pythagorean theorem, and the name of those are what? The legs. I always remember the legs form the L. The legs form the L. And the third side, which we label C, is called the hypotenuse. And it's always the largest side, always across from that right angle. Now, in geometry next year, you're going to talk a lot about proofs and how we know something to be true. Pythagoras in this story just notices a pattern. Does that prove it to be true for everything? No. He noticed it in multiple triangles and tested it in other ones, and we've seen that. You'll get to do lots of proofs next year. Proof may become your favorite thing to do. If you have ever had any older brothers and sisters in geometry, they'll probably tell you no, that wasn't their favorite thing to do. But I did find kind of a cool, what they call a waterproof. It's not a perfect geometric proof, but it's kind of a nice visual of the Pythagorean theorem. And this is just on YouTube, and there's a bunch of them on there. So what we have here, we have a right triangle, and these are squares that are built on each one, so just like Pythagoras built the squares out of the tiles. And these two are filled with water, and right now this one is empty. Emma, will you hit that first light switch? This one's kind of hard to see. It's not very dark. And it's on a turntable, so she's going to rotate this turntable around, and we'll see what happens. A squared plus b squared equals?
C squared.
Does it work the other way? Let's see. There we go. And again, it's not a perfect proof, but it's kind of a cool visual to see how that they add together. Okay. Going back to our example. All right, we're going to do a couple quick examples here. The first one, I have a right triangle, HDG, and I have a leg of 1, a leg of 2, and my job is to find the what? The hypotenuse. Okay, so using a squared plus b squared equals c squared. Which dimensions do we know? A and B, so we'll just substitute those in, and then use our algebra to find c. So 1 squared, 2 squared, c squared will be 5. And so C is?
2.5.
Are you sure?
No.
C squared equals 5, so how do we find C? We take the square root of 5. What is the opposite of a square, or the inverse of a square? Square root. Now, this value, if you type it in your calculator, you're not going to get a whole number. Why not?
Because it's not square.
It's not a perfect square. 5 is not a perfect square. There's not a whole number that I take to the second power to get 5. It's going to be just a tad bit more than 4, isn't it?
Mhm.
Okay. So sometimes it's nice to have that decimal. I always like to kind of look back and say, does that look reasonable for my picture? Yeah, it looks reasonable for, I'm sorry, not a tad bit more than 4. A tad bit more than what? 2. Because 2 squared is 4. So this is going to be just a little bit more than 2. So just a little bit more than 2. 2 point something. Does that look reasonable for my picture? 1, 2, and then just a little bit bigger than that?
Mhm.
Okay. This is the exact value. This is an approximation. Because we know if our calculator is filled with all those digits, we have to round it off. Even the calculator has done some rounding. Sometimes that exact value is what they'll ask for. Other times they'll ask for the approximation. All right, let's do this next one. What's different about this one, Chase? How's that picture different than the last one?
You're trying to figure out the way.
Good. Is this one A or is this one B?
B. A.
Does it matter at all?
No.
No, because if you look at your formula by community property, if you switched them, would it matter?
Nope.
No. So I usually just put that as my missing one for the first one. All right, let's do the math. What's 12 squared?
124.
What's 14 squared?
Mm.
Anyone know that one?
196.
196. Subtract 144 on both sides.
That's why you're on math elite.
All right, so if m squared equals 52, what does m equal?
7.
Square root of 52. Okay, give me the decimal approximation for that.
7.
About 7. Square root of 49 is,
7.
so the square root of 52 is going to be just a bit more than that. Is that reasonable?
Yes.